is Jerome. I work at WeWantToKnow. We're a small startup in Oslo and Paris. How many of you have experienced game development? Yeah, 10%. How many of you know about Unity? More. It's popular. Okay, I'm going to talk about my experience as a game developer, which is pretty recent, and how we use Unity for developing our games. So as I said, we are a small startup. We're based in Oslo and Paris. We're actually 3 French guys. We started as 3. We are now more. We made a first product called DragonBox, which we launched last year. How many of you have heard about DragonBox? Like 10–15%. Okay, so we have 3. We have Jean-Baptiste, he is the creative mind behind the education part. Patrick, who is a game experienced game developer from Paris, and me, who is like an experienced software developer. I was freelancer for 10 years, working a lot with Java and Jenkins automation. So our history, we started the prototype as a part-time work. In July 2011, we started the company in Norway. Early 2012, we launched the first game in May last year. We had quite a few. We had a bit of success, and we won a few awards. And we are launching DragonBox today. This is a coincidence. But it's actually silently launched today. It's going to be official launching today. And if you want to talk about numbers, we have like 85,000 sales today for a game that costs $6. And we support 6 platforms. And how do we manage to support 6 platforms, being 3-person and 1 non-technical level? That's what we're going to talk about. So we today have 2 products. Actually, we had 2 versions of that one last year as well. We only have 1 left, but we support a lot of platforms. And that's thanks to Unity. So for those who don't know about game development, I didn't know about game development at all when I started this project. There are very different roles than typical IT project. That is the one I used to know. You have people, you have graphic designers, you have level designers, you have sound designers, and completely different from database developer, etc. And often you have a game engine. That means something that's going to manage your game. For those who know a bit about gaming, you have Quake, you have the Quake engine, etc. So these game engines, they get to be used across different products. It takes quite a bit of work to implement them. And if you are an indie company and you don't have the resources to create your own engine, then you can reuse an off-the-shelf engine. For example, Unity 3D. Unity 3D is probably today the most known product for developers, indie developers, and it's both an editor and the engine to run the game. That means it allows you to write the game and test it, and also it manages your game when you run it. It supports a lot of platforms from PC, mobile, and console. So, some concepts. I'm going to go quite technical a bit later in the talk. I'm going to have to go quick, but if you have questions, we can address them. And maybe we can keep the questions for after Ulo's talk as well. Maybe we can have the questions answered by both of us, so it makes it perhaps interesting. So if you can take some notes for your questions, that would be nice. Some concepts. So Unity 3D, if you, by the name, it's a 3D focused product, but you can do 2D development. It's not optimized for 2D, so our games today are 2D. You have to kind of work a bit around, and you pay the price of the 3D engine, which you don't really need in our case. That means it causes some issues for performance or things that are not really needed. Anyway, it's based on mono. That's actually pretty interesting, I think. And it comes with its own mono-develop tool, but you could use Visual Studio if you're on PC. You have several languages you can use, C#, of course, Unity script, which is some kind of JavaScript, and you have some very specific game concepts, I would say. The assets, like your sound or your images, those are managed by Unity because they need to kind of pre-process them based on the platform in order to optimize them. You know, if you load an image on a small device, you probably want to have it saved in a format that is not costly to read, so it's going to be large. And if you're on a PC, you don't really care if it's very optimized for size. Then you have the concept of scenes. The scene is kind of a level, okay? And everything that is in that scene, you can kind of, when you discard the scene, you discard the object that are attached to that scene. You have a camera. For us, we all often only have one camera because we are on a 2D, so we are just maybe moving the camera on a 2D plan across the objects that we're displaying. But when you think about any 3D game, you will have a camera for each player, so you have their views, and let's say you are in a simulator or a car, you have the camera inside the car, outside the car, and you can switch between these modes, and the engine will manage all that for you. So it will look at different representations. If you switch camera, it will switch the representation. The game objects, there are all these objects you have in the game. It could be a person. The person is made of different objects itself. And it will be also non-visual objects, something you manage for your code. And the behaviors, for Unity, it's basically scripts, some kind of low-level component, you would say a class, in a language. And these behaviors, they are attached to game objects. So you could have a scene, let's say the introduction of a game, and in that scene you will have a button here, you will have something that moves here, and maybe your button is managed by a specific behavior. When you move your mouse over, it will manage the changing of the button. And then you have the life cycle. As I said, Unity is the engine manager for you. So it gives the ticks for when things happen in the game. You say this scene is started, this game object is now activated, etc., etc. And it asks for this object to be displayed or stop being displayed, etc. It manages all the life cycle of all the aforementioned objects. It helps you to load the assets, etc., discard them. As Unity manages the lifecycle, it has a very specific multi-threading concept. It's not like server-side programming where you can do whatever you want. You have to be careful what you do with Unity. Think more like Swing or like GUI development on a PC. You cannot just start doing threads the way you want. The engine is the one who is a master, and then if you want to do things, you have to carefully manage them. The best way in Unity if you want to achieve some kind of multi-frame, the frame is the unit in which the visual display is going to be managed. You talk about frame per second in a game, and that's one thing happens in the frame. In Unity, if you want to have a behavior that runs across several frames, you can use coroutines, which are, if I'm not wrong, a concept from C#. C# experts here. Then you have plugins in Unity to add external behavior. And then you have the asset store. The Unity community is pretty large. I think there are like almost 50,000 developers today, and they have the asset store where you can upload components that are reusable. Let's say something to manage the 2D environment, or something to manage the translations, or something to do things that are reusable, and you can purchase them. They are either free or paid. And then you have kind of active community with some wikis and things for people and forums for people to discuss the problem they face. We'll make a small demonstration of Unity, briefly. Hope it works. I will test it.
Should you turn off the lights?
Hmm? Wow. That's gonna be fine. So when you're in Unity, you have the concept of scene. I said I can load a scene and make it run. And this is the game. I can directly run the game from the editor, and I can change the behavior and see how it goes with the graphics. Okay. From there, you have a lot of panels. You can see the active. Switch on the volume. You can see the active game objects that you can store in different hierarchies. When you click on an object, you can look at its graphical properties and the scripts, the behaviors you have attached to them. For example, here, this object has different behaviors with some data to initialize it. This is a font manager to display things in different languages. And then this is your project file where you store all your resources, whether they are graphics, scripts, scenes, etc. And it's pretty flexible for you to define your own layout. So you probably have to find on your own. You have a few constraints in order to avoid conflicts, but it's basically it doesn't enforce too much on you. It will say, for example, if you have something called plugins Android, these are plugins for the Android, but you can have them wherever you want in your layout. So if I was to change a scene, for example, and I have made a very small test scene for this presentation. Here, I have a very small test scene. I have a camera. This camera is, you need a camera for a scene to be able to visualize something on it. And I've added a simple C# project, my behavior, called test lifecycle. And this is a very simple mono behavior that will just make an implementation for all the events that Unity manages from the lifecycle perspective, and just log what's happening, so you can see what happens in the console. So if I start my scene, Unity will kick off all the lifecycle events it needs for that particular scene, start the camera, and then start sending events to the activated behavior on that camera. And in my case, it starts displaying things on the console. Now, while the game is still running, I can go and modify my behavior, save it, I wait, Unity updates, you don't see it here with a small thing here, it recompiles the things, and normally it should start automatically replacing the behaviors at runtime and changing things. So if you come from a standard, let's say, Java development environment or even Ruby, this is a live changing of your running project. You know, you need external tools to do these kind of things on standard projects. I think this is very powerful. It makes very, very quick turnaround when you change something and you want to see how it looks like. So, yes, so that's all for my very quick demonstration of how Unity works and the ground basics. And I'll go on the cross-platform aspect. So as I said earlier, thanks to Unity, we support lots of different platforms. On our game today, Windows, Mac, iOS, Android, we have a web player version, we have a Flash version, we have a Windows 8 version, 7 platforms. Not all of them are published, we are using some internally, but we're going to soon have 6 sold platforms for this project. And this is one code. Okay, it's the same code. From a Unity perspective, you need to have the different platforms here, and to have them, you need to purchase the different plugins. This is not free, and Unity is not free. So once you have purchased the proper plugin and registered your proper license, then you can, when you develop, switch the platform if you need. If you have some platform-specific things you want to verify. This will make Unity prepare the assets, like the media and the sound, for the target platform. So you'll be able to check the obvious platform differences there. And then you'll be able to build using this build component. Depending on the platform, this will either build the target project. Let's say Windows will be built right away. You have an exe file. But if it's something a bit more complicated, like an iOS project or Metro or Flash, you have a second stage as part of the build. And it creates a project that is going to be actually good. So in the case of iOS, for example, it creates an Xcode project, or it updates it if you already have one from the previous build. And then you can use Xcode to build your iOS project. I mentioned Flash earlier. I make a small correction. The Flash is entirely managed by Unity, but it's still a 2-stage build process, and it takes quite a long time. For Metro, you create a Windows, Visual Studio project, and then you have to build it from Visual Studio or from your own scripts in order to generate your target project. So when you want to test the actual build and you go out of the editor, the turnaround for testing is much longer. For our small projects, some builds take 5-6 minutes. So you go from a few seconds to 6 minutes. So when you start having problems that are platform specific, then you hit a wall. Other things you can do from Unity, you have some pre-configurations. The tool allows you to define the things that are typical for your target project. Let's say on Android, you can define the icons, the splash image, the etc., so that the tool will manage a proper project for you. These are the standard default things you might need on a project. That way you don't need to go and fiddle with the Android manifest if you need, or these kind of things. But of course, not everything is managed, so at some point you might need to go and do some specific things. There comes the plugins. In our case, for example, for Android, we manage the Android manifest because we want to change the default permissions that are generated by Unity, and so we do a few things there. We have also external plugins that add cross-platform code. Let's say to manage the analytics of the game, how people are using our game, or to manage some particular features that we purchase plugins on the asset store when we need, etc. For Flash as well. So how do you do cross-platform, or like platform-specific code? How do I change the behavior, something that is not supported by Unity? I can use Unity to say vibrate, because it has an SDK for vibration. And it's cross-platform, it will be implemented on the platform that supports it. But if I want to do something that is not supported by Unity SDK, then I need to go native. How do I go native? This is an example for Android. I don't think you will see from the background, but basically what I have here, anyone use GNI on Java for Python native bindings for Python, etc. What it does here, it exposes some .NET classes, C# classes, that actually are wrappers around the some Java classes. So you can create call some behavior from C# that actually map to Java code. Here I'm creating a new Android Java class that is the Unity player, and from that one I'm fetching the current activity field on that class. It's a static field, and I'm storing it in a variable here, and then I'm calling the method getWindow on that particular field, etc. So the same Java code is probably much smaller and less verbose, but I don't need to create a plugin, and I could do that, but I don't need to do that in Unity. I could just write these few lines of code, and it works. As you might see here, I have also some defines. So when it comes to code and you want to invoke some parts of your code on a platform and some others not, you can either use compile blocks like defines to take out some behavior, or you can use some dynamic checks to validate whether or not this part of the code you want to execute will be executed or not. We, for example, a quit functionality that you have on Android on our game, we display a quit button to exit the game. You're not allowed to do that on iOS, so we have some functionality like that to show or not the features based on the platforms. You can also use this for bugs. If you have some particular issues when it comes to the code, you have to, let's say, on Windows 8 we had a few issues to work around, and we have some platform defines to solve. And in fact, we have found plenty of bugs. This is the list of the bugs we reported, some of them.
Starts from one?
No.
Page number?
I don't know. The thing is that the blog report platform from Unity is not open, like you might think of IntelliJ, for those who use IntelliJ or something. They have a pretty closed environment. So these are my bug reports, and nobody else can access them. And but they are in increasing number. So it's 532,000 was my last one. And you don't see it here, but a lot of them are still open. Okay, some limitations. I think I won't go in detail here. I'll explain some of the limitations I see coming from non-gaming work. Platform-specific performance, because Unity has to work on the target platform. Sometimes I'm not allowed to do some things on that particular platform, and it makes their engine not optimal. We don't have that many problems. I would say Flash is very CPU intensive for us today on our code compared to what it should be, and maybe the Windows 8 could be better. The portability per language, some features, when you start porting with a new platform, you found out that this particular feature, language feature, for example, that you were using, is not working, or this particular API method is not supported. So you have to work around. So you have to rewrite some of your code. Restrictions are, on the Windows 8, the new RT API is much more restrictive, and you cannot do everything you want. The bugs per platform this is, like I said earlier, the round trip when you start working on the native and to find out problems is much longer than the typical development you have when you work within Unity. You go from seconds to several minutes. So when you face bugs that are specific to a platform, it becomes really frustrating. But there are not that many actually. So we've been pretty lucky. We started with 3-4 platforms from the beginning, so it helps us a lot to add new platforms. A few weeks of work and we have a working product more or less. Documentation, I think that the Unity documentation could be better, but every game developer I've talked with was pretty satisfied with the state of Unity documentation. But when I find an API that doesn't have documentation for the return code, I get really frustrated. But they are happy to see some documentation for us. So different expectation. Price is pretty expensive. Because we do a lot of automation, as you're going to see, we have to have the Pro version, and the Pro version for all the plugins. It's like $1,500 for every single platform, and you run it per machine, and you have it for all the build servers, so it starts to be expensive, $6,000–7,000 for software license for one machine. So we don't use all the plugins for all the developers. We have one build server that has all the plugins, and then we just buy the one we need for our own development. Time, it seems. Yeah. I'm going to talk a bit about mobile development. This is something that was completely new to me. I made a few Android apps like for fun, but never like tried to sell anything. So this was new when we started. So, how we work, I don't know at all if everybody does things like that. We make a prototype, and the prototype in the gaming world means 2 to 5 days of work, and you have something, thanks to platforms like that. I mean something that is visual and work, and if, of course you cannot sell it, but you have the basic concept you can test and go from there. Then we work and we make it a final product, and that takes much longer time. And when it comes to porting, as I say, we spend a few weeks to ensure that it works properly on the platform. Basically, we're going to have to add a few pieces of code that are not that are required to add the functionality on those platforms, or to manage the platform differences. Let's say we started with iOS, and all the platforms were 4x3 on the screen. And then we added Android, and they are not 4x3, so they started to have a lot of different constraints, and etc. User testing. For us, user testing is critical. We go and we make products for kids, and we go and take kids, I would not say every day, but I've been countless times outside of schools with my pad. With sweets. I've not been in jail yet, so but we do this a lot, and it's very important. You're making something that is, you make a control. Like control is the interface between your game and your user. It can be a mouse movement, a touch movement, anything. And you think it works, and it doesn't work for everybody. You find very strange. That person has fingers that doesn't work with iPad. I mean, like, you find very strange stuff. People try triple clicks, double click, slide at the same time, and it's like very, very strange thing. So you have to have feedback from actual users, and especially on the tutorials. We are making a learning tool which has less text as possible, and you want to see how people react to these informative tutorials. Reporting bugs. A lot of bugs, we find them by watching the people playing. I have had countless kids at my place. I film them. And I watch their bugs. And we also have some tools from within the game that you can use to report crashes and stuff like that. Then app stores, so that's a special section, and automation as well. So app stores. How many of you have tried publishing something on Azure App Store, Google Play, or a few? How many things the experience was, let's say, enjoyable? Wow.
Depends which one.
Which platform was it enjoyable?
I've tried lots of them. Google Play is actually pretty nice. It's the best one I've tried so far.
Same experience. So we're not going to mention the bad ones. You have lots of things when you want to put a game or a product on an app store. You have to have descriptions, so with some constraints, number of characters, different platform. You have screenshots that you have to place, one by one, sometimes. Lots of screenshots. Per language, different resolutions per platform, and sometimes multiple screenshots. Promotion, yeah, you want to be promoted, that's great. You reach the grail on an app store, you're one of the app selected this week for promotion. You need to add some graphics, again, and different resolutions, and etc. etc. Translations, you think it's going to be cool. You're going to take my game and make the specific app store page for Korea. Yeah, the description in Korean, the screenshots in Korean. The promotional text in Korean, manually upload it to the App Store. Environment. Once you're there, you're already asking the ranking right now. You have to select your prices. So for Apple, it's very nice. You select your tire. You say a price tire. I'm tire 6, and that's going to be $6 in the US, and then find out how much it should be in all the other countries in the world. That's very nice for you because you don't have to think. And then your game costs 350 rupees in India, which means nobody will buy it. All the other way around, you can go to the Google way, where you're very flexible. You're going to define every single price, and you have to find out whether or not you need to include VAT or not. Compute the price from there, and then you can define it for every single country, which is like a nightmare when you want to change the price. So once you're there, you probably have sold some games or some apps. Then you want to track the rankings, so you can use some external tools to track your rankings, different player platform, and often they are not supporting all the platforms you want, at least today. Let's say Windows 8 comes later in the game. You want to try to have some automation. We have some tools for fetching data for the developer website from Apple, because it's a pain to manage. So we wrote some scripts for automating a lot of things there. I didn't mention the promo codes that you can have to distribute to people, but you have, that's on iOS. Promo codes, you can get 50 promo codes per release on the App Store, and they are available even if the game is not live, so you can use them to journalists. You don't have that on Android because you don't have promo codes, but on iOS you can also buy these redeem codes if you want to give the game for a friend. So you think you're out of promo codes, you can buy a redeem code and send that to a journalist. Use this to buy the game. You can't because you're not in the same country, and the redeem codes are country specific. So if you say if only you move out of Norway, you want to sell games to your grandchildren in Norway, you can't. Etc. etc. And then you have all the SEO, that's your website search engine optimization. You have a new cool thing called App Store optimization, where you're trying to find which keywords you should define for your game to appear when people search for your app. Unfortunately, even on Google Play, you don't have access to some kind of website analytics. You could think that from the Google Play page, you see where people are coming from, which article they came from. So you have some idea of what is working best for you. You can do a few things based on trying to have some conversion tracking, but then it's not. Yeah, I'll let that outside. But to track this, try to manage how to get your application ranked high is their platform optimizations. On iOS, you have to select a few keywords. The specification is, I think, maximum number of 99 characters, including commas for the list of keywords you use. And of course, you start with English, and then you make your list of 9, 10 words. Define your application that you hope that your users are going to use when they search for your app, so you try to get ranked high. And then you get this to be translated to French, and the 10 keywords are now not 99 characters, but 120, so you have to take some out. It's a lot of details on that nightmare. So we try to automate as much as we can. From a build perspective, from gathering numbers perspective, etc. So I'm a continuous integration fan. We're not doing full continuous integration of these products today. We're doing a lot of build automation. We're doing a few task automation. I don't have the test automation I would like to have, but we have a lot of task automation around the project. So these are the list of some of the projects I have on my build server. You don't see them, unfortunately, but I have a lot of game per platform, for example. And then a lot of infrastructure tasks, backups, fetching data from the server, fetching the list of websites that triggered a user to come on our sites. tracking tweets about us and gathering them into the database. Anything, fetching data from Apple and storing it locally or updating it, etc. So this is our build matrix. And test flight, I forgot to mention. When you want to test and get a user to test, you have a few testers in the office, but you some are outside of the office. And for everything that is either iOS or Android, you want them to get them on device as easy as possible. And we're using the site called Test Flight for that, for those who don't develop, or for those who want to write Android or iOS apps. I would definitely ask them to consider to use it. When I make a build, when one of my developers make a change through Git, it's pushed. My job accepts the change, makes the build for all the platforms actually, and depending on the platform, it's going to publish either a zip file if it's a Windows version, either the Flash is published on the server for testing. The Android is sent to test flight, and the users registered in a list of allowed users for receiving automatically the build, get notification, and they can just go on their mobile and download it and test it. So from the moment one of my developers makes a commit to the moment the game is on their phone, it's like 15 minutes. So I think it's pretty nice. Okay. Services we use, I said test flight for deployment, Distimo to analyze how Distimo and Admin, I can mention here, we have two services to analyze how good your sales are. It integrates with the different app stores. We retrieve financial data, the download data, and then presents you so you can search for them based on the country, the mobile platform, or the app store, Google. You can make cross-references and try to organize your data and see what's going on. So when you have some spikes in the sales, you can quickly see whether it was only one platform or all the platforms. You can tag them and say this was because of that particular article in that country, etc. We use GetClicky and Google Analytics for website statistics. I like GetClicky a lot. It's live, and they also do things like Twitter searches, and at least it was working on this week. But they do Twitter searches, so they back up all the tweets if you make some predefined searches. That's practical because the Twitter API doesn't let you search tweets more than a week old, I think, something like that. So if you want to store your tweets, you can use the service for that. And then we have a few scripts written in Ruby, mechanized to scrap data from different websites. Okay. Yes. Conclusions. So when we started the project, we were 3, 1.5 developer full time, I would say, and we managed to release 2 products on 6 platforms in, I would say, half a year. So yeah, I think a lot of time was spent afterwards for bundling everything. Started in July, maybe a bit more than half a year, 9 months. I think we managed to do this, well, in part thanks to Unity, because we have one code base and we can publish to all these platforms. Thanks to Git, it's very practical to manage branches, and I think it fits very well with at least the pro version of Unity, which stores all these assets in text, and non-pro doesn't work with only stores binary. We do a lot of automation, and we wouldn't be able to do this without automation, and a lot of services we use allow us to do what we do. Things are changing very, very fast, and so if you have questions, I said maybe we can take them together with Uber. Then we can have 2 different perspectives. I think it's cool. As I said, we just released DragonBox 2 today. It's silently released, and it's coming officially in 2 days out. And if, for example, someone buys it here, I'll show you how you get it. You get the information from the Google console live. Yes. Okay. Thanks.